Alright, please take a seat. So today I'm going to introduce what is Vue and how you can use it. So last time we learned how to define a view using this with clause. I mean, when you use with clause, it works like a macro. So the view name and its definition is used for the subsequent query. So when you use that, how should I say? Let's go back to with clause. Oh, is it in the previous lecture slide? Maybe. Anyway, so this view is similar to the with clause, but unlike with clause, view will persist, which means when you terminate your query using semicolon, the with clause will not affect following queries. So you can define the macro only for a single query. But in this view, once you create a view using create view statement, the view can be used for any subsequent queries. Multiple subsequent queries can use the same view. So let's see how we can define a view here. Create a view and view name follows, and the definition select the query follows as keyword. So the main purpose of defining this view is to hide some information from certain users. So let's suppose we have instructor table in our database, and instructor table has an instructor ID, name, and department name, and salary. And sometimes we may want to hide this salary column for certain users. This is credential information. So if you want to hide this column for certain application or users, then you better create a view without this salary column. So when you run this create view statement, you select ID, name, and only these three attributes, department name, from instructor, and you do not select the last salary column. Then a logical view will be created, and you can give access permission access permission of this faculty view to certain users. Then those users will be able to access a faculty view, but they will not be able to access the salary column of instructors. So let's consider this query. This query creates a view named bio faculty. And what we do is, we created the view named faculty from the previous slide, and we are using the view to create another view. So this next level view also doesn't show salary column, and it only shows the instructor's name from biology department. So you can create another view based on any existing view. And once you define faculty view and bio faculty view, you can use those views just like they are, just like normal regular tables. So this bio faculty will behave as if it is a regular table. So when you select everything from bio faculty, where name is like this pattern, then only the bio instructor's name and ID and department name will be selected from this query. And of course, the salary column will not be shown because bio faculty is based on this faculty view, and faculty view doesn't have that salary column. So when you use this view in a query, what actually happens inside the DBMS is this bio faculty will be expanded into the query, view definition. So the view definition is shown here. It is just select the query. So this biofaculty, this view name will be replaced by this select query. And again, we have another view name inside this query, nested query. So this faculty view will be also replaced by the definition shown in the previous slide. So this view is purely logical. It is not actual table that consumes disk space. It is just a query definition. Next, this view name can be used in insert query. When you insert these three data into faculty view, 3 will be stored in ID column, and Charlie will be stored in name column, and music will be stored in the department column. But as I said, this faculty view is logical concept. It is not actual table. So when you insert a record into a view, what happens inside the DBMS is that this data will be actually inserted into instructor table, the physical table. We have a problem. This view doesn't have a salary column, so you are allowed to insert only 3 values into this faculty table. So you are not allowed to insert the salary of this instructor into faculty table. Then what should we do for the salary column? We do not know the salary of this new instructor named Charlie. So DBMS will insert a null value into this salary column. And there are alternative approaches. It depends on what DBMS you use. Some DBMS will store null value for that unspecified column, but it is possible for DBMS to reject that insert query. So if you try to insert a new record into a view, not the physical table, then the insert query may fail. But most DBMSs insert a null value instead. But it is possible that this salary column may not allow null value. If this salary column doesn't allow null value, then of course this insert statement will fail because null is not allowed. And our Postgres stores null value into this salary column. And so far we saw a very simple view definition, but view can be defined using natural join operation. So if you look at this query, if you look at this view definition, this view named instructor info is defined as these columns, a table with these columns, and those columns will be filled from instructor table and department table. So after we perform natural join operation, we select these columns and define that output table as instructor info. So let's assume we have an instructor table like this. So it has 2 records, and department table also has 3 records. And when you perform natural join, we are going to get these 2 records, Alice and Bob. Electrical engineering is removed, and we have only these 2 records. And this view definition doesn't include the salary column, so salary is not shown here. And let's suppose we insert these 3 data into instructor info view. Then what should we do? We do not know the department name. So should we insert null value into department name column? Like we know ID, so ID should be 4, and name is David, and we do not know the department name, and we do not know the salary. Okay, maybe we can put null values, 2 null values. But what about department table? Here we should insert a new record, and we do not know what is the department name. And so should we insert null and Watson? Not clear. This is very unclear. So most DBMS doesn't allow you to insert records into a view if the view is defined using join operation. If the view is a very simple query, I mean, if the view is defined using a very simple query, then insertion is allowed. But if the view has some complicated operations like a join operation, then insertion is not allowed. All right. What about this? What is this? Here we don't have a natural join. We are just selecting everything from instructor, and department name should be equal to history. So we created a view named history instructor, which is just a subset of instructors. Only instructors from history department will be included in this view. And since this is simple query, maybe DBMS allows us to insert a new record. So let's insert this new record, Brown from biology department. Oh, should we allow this query? History instructor is for instructors from history department, but this guy named Brown is from biology department. If we allow this, if we allow to insert this data into instructor table, then instructor table will have a new record, but this newly inserted record will not be shown in history instructor. And that is confusing, right? It may surprise developers or application.
The instructor table is updated with this value.
Yeah, so whenever you insert a record into a view, the record will be actually inserted into the original table. And view, when you access a view, DBMS will simply run select query to retrieve some record that satisfy the given condition. But if you insert this Brown into instructor table, it's not going to be shown in the history instructor. So people will think, oh, I inserted a new record into history instructor, but it is not shown in history instructor table, I mean view, but it is only shown in instructor table. What happens? It is going to make people confused. So most DBMS allows insertion or update only on very simple view. The from clause must have just one single database table, and there should be no where predicate, and there should be no aggregation. I mean aggregate function like a sum, count, they shouldn't be used in the view. And also this unique operation, distinct operation should not be used in the select query. Only if these conditions are true, we allow to insert a record into a view. Also, group by is not allowed, having is not allowed. Okay, any question about view?
And the join operator can
Not be used. I mean, you can define a view using join operation, but if you define a view using join operation, insertion will not be allowed. It will be only read-only table. I mean, read-only logical table. Okay. Good. Next, transaction. DBMS is all about transaction. What is a transaction? Transaction is a set of SQL statements that must be executed as if it is a single instruction, single load instruction or store instruction. So when you learn, when you take computer architecture course, I mean computer organization course, you will learn machine instructions like load, store, comparison, those machine instructions. They can be executed in a single CPU cycle, single CPU clock. And they are atomic operation. But in DBMS, most operations are the sequence of those machine instructions. But sometimes applications want to execute those set of instructions as if it is a single operation, single atomic operation. Then you should use begin and commit statement. Inside and between begin and commit, you can put multiple insert or select or update or delete queries, and they can be of course separated by semicolons. So this is not a single operation. This is not also a single operation, but when you include these queries inside the begin and commit, and these operations will be executed as if it is a single atomic instruction. What it means? What does it mean? So here we are inserting Ellie into a student table, and we are inserting this course information. It seems Ellie took database course, so we want to insert this record into student table and this record into text table. Unless both operations succeed, unless both of operations succeed, none of them will succeed. So there will be no partial state. Ellie and SW3003, these two records should be shown together, or none of them should be shown. Okay? That is concept of transaction. And although we haven't learned it yet, we can put some, conditional statement inside this begin and commit. And while you are running some insert statement, you found that a certain condition is not satisfied, so you may decide to cancel all the operation. Then instead of commit, you should put a rollback. This rollback will cancel everything you performed starting from this begin statement. So commit means success. Rollback means failure. So if anything bad happens during this transaction, you should roll back to cancel everything, as if none of these operations have performed. Okay, that is rollback operation. And we are going to talk about these transactions a lot more in detail in chapter 17. Next, integrity constraint. So when we create a table, you learn that we can declare that a particular attribute cannot have a null value. You can put non-null keyword after the domain name, then that particular attribute does not allow you to store null value, right? That is an example of integrity constraint. So this slide lists a couple of examples. Suppose you want to make sure that a bank account cannot have a negative value, negative amount of money, or you may not allow customers have null value in a phone number column. And I don't know, maybe you just read more. So some applications require certain limitations or constraints, and those constraints can be declared when you create a table. So non-null is one of the examples, and primary key is another, and unique is also another constraint example, and check is the new one. What is check? You can put any predicate inside the parentheses, and only if this predicate is evaluated true, that value is allowed to be stored in the table. So let's look at one by one. So non-null constraint is shown here. We haven't seen non-null constraint a lot, so you can just put non-null keyword after the domain name, data type name. Then name will not allow to have, it is not allowed for name attribute to have null value. And unique constraint is how we can define a candidate key. So primary key is a selected candidate key. What is candidate key? Candidate key is a set of attributes or just a single attribute that can uniquely identify a particular record. Okay, that is candidate key. So this unique constraint enforces to have a unique combination of these attribute values. I mean, let's say you declare that student table must have how should I say? Let's define it here. So let's say A1 is name and A2 is department name. Okay. So suppose that when you create a student table, you put unique constraint like unique parenthesis, left parenthesis, name, comma, department name, and right parenthesis. Then every department can have, every department may not have duplicate student names. So combination of name and department must be unique. So like computer science, let's say Alice is in computer science department, and maybe there's another guy, another student named also Alice, and if you try to insert this record into the student table, because of this unique constraint, the second insertion will fail. Okay, that is unique constraint. And we already have seen many primary key examples, so let's move on to the next one. And the last constraint that we need to learn from this lecture is the checker constraint. So checker constraint allows us to specify any condition, as long as the expression returns true or false. So let's look at this example. We are creating section table, and it says that this semester attribute is a virtual type, and its character length can be maximum 6 bytes. And in the last line, it says that semester should be a member, an element of the following set: fall, winter, spring, or summer. So if an application tries to insert fall into this semester column of section table, it will succeed because this string is a member of this set. But let's say if you try to store just F as your acronym of for, it's going to fail because this value is not a member of this following set. So in operator checks the membership, and only if this expression returns true, that attribute value is allowed to be stored in this section table. Question? No? Okay, let's move on. There was one more. Another constraint is called the referential integrity constraint. Usually, people prefer to say foreign key constraint. This is just another name of a foreign key constraint. What is a foreign key? Remember? Yeah, primary key of another table is called the foreign key. So this referential integrity constraint, another name, also known as foreign key constraint, checks if the value of my table exists in the primary key of another table. So consider this example. We have a customer table on the right, and on the left we have order table. So this left table stores which customer, who ordered what items. Customer ID is in the middle column. All right. So currently, all these values, byte, I don't know how to read it, byte boy exists in this customer table, and Fitchburg also exists in customer table. So currently these two tables satisfy the foreign key constraint. And then let's suppose somebody executed this insert statement. This statement tries to insert a new order with ID 4 and invalid ID into custom ID and 346 into item ID. So when this insertion statement is executed, DBMS will find out that, oh, this order table has a foreign key constraint. So I should check if this second value exists in a customer table. And it will find out that, oh, this invalid ID invalid ID doesn't exist in this customer table, the primary key. Then this insert statement is going to be rejected by DBMS. Okay? This is called referential integrity constraint. So how can he declare such referential integrity constraint? It is shown here. So just like other constraint, unique or primary key constraint, when you create a table, you put this foreign key, you put this line that begins with foreign key keywords. And inside the parentheses, you should list a set of attributes which is the primary key of a remote table. So this custom ID, this line declares that, oh, this customer ID is the primary key of this remote customer table. So this custom ID column in my table is referencing this remote table's primary key. So whenever I insert a new value into my customer ID table, my customer ID attribute, I should check, DBMS should check the value is a valid value that currently exists in remote customer table. Okay? Question?
Should the name of customer primary key attribute's name and the foreign key name should be equal, or?
That is actually a really good question. I believe not. It doesn't have to be. It doesn't need to have the same names. Oh, I'm 99% sure, but I could be wrong. You should try. I can try, but yeah. It's your private assignment. Try it. All right. Next. I don't know. Oh, yeah, I was right. I think I'm right. So the next example exactly shows that. So let's suppose this customer table has a primary key named the customer name. And if my table's attribute name is different from this another table customer's attribute customer name, they have different names. So to make sure that this cost name attribute is referencing customer name attribute of customer table, it is better to explicitly specify those two attributes, a pair of attributes. Okay. Next. So consider this case. Again, we have customer table and order table, and these white colored records are related, and these two yellow colored records are related. And what if we delete our record from the table that this order table is referencing? If we delete Fitzbug from customer table, it is going to violate this foreign key constraint because these two records are currently referencing the second record of the customer table. When you delete it, this customer ID Fitzbug will become invalid, right? How can he keep? How can he guarantee this consistency even if these remote records are deleted? You can specify particular actions in the foreign key constraint. So it says that this order table, the left table, is referencing customer table, and if this customer table, if a record is deleted from this customer table, its related records in my table should be deleted. Okay? And it is possible that this customer ID can be changed. If somebody changes this customer's ID, let's say he changed his ID from Fitzbug to, I don't know, XYG, then that update operation will also update its corresponding customer ID in order table as well. Okay, so this deletion or update operation on this reference table will trigger cascading actions. Okay.
Is this action inherently atomic, or you have to specify it?
It should be performed atomic. So by default, every statement that ends with a semicolon is treated as an atomic transaction. So they must be executed atomically, even if we do not include this statement inside the begin and commit. These two operations must be executed atomically.
What happens if updating customer ID with order table, not customer table?
Then the update operation is going to be rejected. It's going to complain that you are violating this foreign key constraint. So here, when you delete the Fitzbug from customer, its relevant records from order table will be also deleted cascadingly. Cascading action. And instead of triggering that cascading action, it is allowed to perform different actions. So instead of deleting or updating, you can just change its value to null. Or you can specify a default value. Instead of null, you can specify another value as the default. So let's look at this example. Here, when you when you create this order table, you put this default option. So if somebody tries to insert a null value into customer ID, DBMS will store this string instead of null. That is what this default means. And once you define this default value, you can also put that default value for this foreign key constraint. If someone deletes a record from customer table, then cascading fashion, its related records in my order table will update those affected attribute values to the default one pending. So when someone deletes this Fitzbug from customer table, these two records will change their customer ID column values. Okay. And instead of using this set default, you can use a set null. Then in that case, when this second record is deleted, these two yellow colored records will set null to customer IDs. Okay? Question? No? Good?
ID has a constraint that cannot have like a super, if the attribute has a constraint that cannot have a value in null, and if you do only sender, then does the vector be rejected or?
That is an interesting question. So what if customer ID has a non-null constraint, and what if the foreign key constraint says we should set null value on delete? I guess the create a table statement will be rejected. Okay, good, interesting question.
딜리트에 넣을 된다는 거는 애초에 포인키 값에 넣을 넣는다는 거예요.
Mm-hmm.
그럼 예를 들어서
Mm-hmm.
커스터머를 딱 안 지우고
Mm-hmm.
포인키 자체를 직접 넣으러 바꾸려는 시도도 되나요?
Yeah, you can do that. His question is, let's assume this case. We haven't deleted this fetch bug from customer table, and if customer ID doesn't have non-null constraint, we are allowed to store null value, right? In that case, is it okay to change these values to null first? Yes, we can do that. Good. And what is this? Oh, self-referencing table example. So here we have just one single table, person, and we have, strangely, we have a foreign key constraint using the same person table. Do I have an example? No, I don't. So let's just suppose we want to store grandmother's name into this table, and father's information into this table, and son's information into this table, something like that. We have mother, and mother's grandparents' information is also here. Let's suppose we want to insert this genealogy, hierarchy information into this table, and to enforce this integrity, we want to make sure that mother's name, father's name exist in the person table. So we put these two foreign key constraints. Then we have a problem. How can we insert grandmother into this person table? Then should we insert grandparents information? Then what about those grandparents? And should we insert the grandparents? So it's not going to end. So the solution is to allow null values. So even if you have this foreign key constraint, I think this slide is related to your question. So even if you have a foreign key constraint, it is allowed to have null values in those foreign key. So although this mother and father should reference name attribute, as long as we can store null values in mother and father columns, we can store the initial person, the oldest person, into this table. The first ancestor can have null values in father and mother. Next, checker constraint. This checker constraint can have nested query. So here, in the previous checker constraint example, we used static set with particular varchar type string. But instead of specifying static set, you can put select query. Then whenever someone tries to insert a new record into this section table, this select query will be executed, and this set will be generated, and then this attribute value, DBMS is going to check if this attribute value is included in the output table of the following select query. Okay. Question? You can use what? View? View. I think you can do that. Can do that. I have never tried it, but you can do that. I believe so. There's no reason to prevent from using that view in created table statement. Next, assertion. In high-level programming languages, we can check some conditions using assert functions. Have you guys used it? For debugging purpose, many programming languages provide this built-in assert function. And just like that, SQL also allows us to create an assertion. And this create assertion should use checker constraint. However, we are not going to cover this because none of the DBMSs currently support this assertion statement. Although this assertion is specified in SQL standard, even Oracle didn't implement it in their DBMS, so it's not supported. So I guess we can skip this slide. Next, data type. So we learned DBMS supports varchar type, char type, int type. Let's look at some more data types here. Date is supported. Many web applications use this date information. Then you can you can have a date type attribute. And if you need time, you can also you can also have another attribute of time type. And timestamp is a combination of date and time. These two informations can be stored in the same attribute of timestamp type. And interval type is the type of the output of arithmetic calculation using timestamp or date or time type data. So if you, let's say, A is of timestamp type and B is also timestamp type, if you deduct B from A, the output will be of interval type. And this interval type values can be added to date or timestamp values. Let's move on. Large object type. DBMS is not particularly designed for multimedia data. Usually DBMS has been used for small documents and small enterprise data. But as multimedia data, the size of multimedia data is becoming large, and also lots of multimedia data generated on the internet. DBMS started to support new data type called blob type and club type. Blob stands for binary large object, and club type stands for character large object. So you can create a table like this. Let's say SNS posting table. So SNS posting table may have user ID and when the posting was made. You can have a timestamp type attribute, and you can have a blob type attribute where you can insert a video or a picture. So 1, 2, 3, let's say yesterday, something like that. So you can store raw multimedia data into database table. And also DBMS allows us to define user type. So, in high-level programming language, you guys are allowed to define a new data type using type-def statement, or class or structure. Right? Using these constructs, you are allowed to create a new data type, and just like that, in DBMS, you can create a new data type using create type statement. So here, in this example, the usual data type is called dollars, and what it is it is basically a numeric type with 12 digits and 2 digits as a decimal point. So, these 2 digits are for cents, and these 12 is for dollars. And once you define this usual data type, you can use that data type when creating subsequent tables. Next, final. I don't think this is important, but so suppose you created a usual data type named person, and you can create another data type using the data type you created earlier. But you may not want other developers to extend your data type. In the case, you put this final keyword to prevent from other developers to extend your data type. Without final, here we don't have final, right? When final is missing, the data type can be used to declare to define another data type. But when there is final, this type cannot be used to define a new data type. This is not allowed when there is final. That's what final means. And domain. So far, I have used. Sometimes I said type. Sometimes I said domain. They can be exchangeably used, but the actual meaning of domain is the data type with checker constraint. Data type with constraint. So an example is shown here. Here we are creating a new data type named degree level, and it is actually a virtual type. But in addition to this data type, this domain allows you to specify some constraint, and the constraint can have a name. So the constraint user defined constraint name is called degree level test in this example. And what this constraint does is it checks a value that is going to be stored in this domain must be either bachelor's, master's, or doctorate. So we put this checker constraint and data type together inside the domain. That's what domain is about. And next, index. Suppose you have a really large table with millions of records inside. And suppose that table is frequently looked up. So finding a particular record from the large table takes very long time. It may take very long time, and you want to improve performance. How can you do that? If you want to improve the access performance, you should use an index. What is index? In data structure class, you learned hash table and binary search tree structure. They are index. In database management systems, we use B+3. B+3 is the most popular index in DBMS. And our textbook will cover some hash tables, advanced hash tables. But hash tables are not as popular as B+3 because hash table doesn't keep the order of records. B+3 just works similar to binary search tree. So if you look at the leaf level, all data are sorted in ascending order or decreasing order. when you use hash function, data are scattered across multiple different buckets, and the ordering will be completely messed up. And that is what makes hash table less popular in DBMS. Anyway, so if you find a particular table is too large and its access performance is very terrible, then you better run this create index statement. Create index, and the user defined index name follows, and then on follows, and the larger table name should follow. And if you want to build an index on specific attribute of this table, you should put the attribute name. And usually the index is built on non-primary key. So although this is an option, usually we use attribute name and table name together when creating an index. So let's look at this example. This table is a student table, and ID is the primary key. ID is the primary key. You can create an index on name, or you can create an index on department name. But in my example, we are building an index on the primary key, ID. So this is the user-defined index name. But this index name doesn't really matter because subsequent queries will never use this index name in their select query. Once you build an index, DBMS will decide to use this index or not, depending on the query execution plan. So index name doesn't really matter. And most DBMS do not support the hash table as their index, but in SQL standard, if you want to create hash-based index, you need to put this using hash option. And we will cover details about these indexing structures in later chapter, right before the midterm exam. And that is my favorite chapter. Index is really fun to discuss. And next, authorization. We are almost done with this chapter. So, DBMS is a single process running in a shared machine. And inside the DBMS, we can have multiple DBMS users. And the single DBMS may have multiple databases, and DBMS can control which user can access which database. And those access permissions can be classified into these four privileges. Some users may only have read access, and some users may have only insert access or update access, delete access. And this access permission can be controlled by only the super user. So if you want to try these grant statements, you shouldn't use our image cluster because you are not super user, you are just regular user. And if you want to try it, install Postgres or other DBMS in your PC or laptop and try these grant statements. So to give an access permission to a particular table to a particular user, you should run grant statement. So grant is followed by read, update, insert, or delete, or simply you can put all privileges. And after the privilege list, you should put own keyword and then table name. So here in our example, we are controlling access permission for department table here. And then the user list should be separated by comma, and this user list follows two keyword. And if you suppose you want to allow everyone to access this department table, then instead of specifying particular users, you can simply put public after two keyword. This is going to give access permission to everybody. And instead of all privileges, you can give only select permission, insert permission, update permission, and so on. And sometimes you may want to revoke those privileges from users. Then you use revoke statement. So grant statement is using to keyword at the end, but revoke statement is using from keyword at the end. So if you look at this example, we are taking access permission from these users back. So these three users will not be able to run select query on student table. Okay, that's it. Any question? No? Good? Next, JDBC. So SQL is declarative programming language. You just specify what you want. You do not specify an algorithm. That makes this SQL so popular. But some advanced, skilled programmers may want to implement some algorithms instead of just letting DBMS to decide. Programmers may want to explicitly specify how this table should be accessed. Okay. Then you need some programming constructs like if, else, while, for loop. Those things are needed. But in SQL standard, those programming constructs are not allowed. And also, SQL is only about accessing data. DBMS doesn't have functionalities about some user interaction. Its user interaction capabilities are limited. So if your application needs to print out some papers, then SQL DBMS is not the way of developing your program. And also, if your application needs some fancy user interface, then DBMS SQL prompt is not the solution. So SQL and high-level general-purpose programming languages are usually used together. And so there should be a way of combining your Python program with DBMS, Python or Java program. For that purpose, database people developed two libraries. One is called ODBC and the other one is JDBC. So what is ODBC and JDBC? This is about database connection. So your high-level programming language should make a connection to DBMS, and your program should submit some SQL queries to this DBMS using that connection, and DBMS will return output table using again the same connection. Then your program should parse the output table and show the output results using web interface or mobile app interface. That is the role of this high-level programming language. JDBC stands for Java Database Connection. So JDBC is a Java API, and Java is the most popular programming language for database applications. The main reason is Java is more stable, more reliable than C or C++ language. So when this Java and DBMS applications were developed, Python was not a very popular programming language. Python is a relatively new programming language. So at the time, Java was the most popular, and that made JDBC and Java-based web applications the most common programming language to develop these enterprise applications. Anyway, so when you use JDBC, you need to use a Java programming language, and inside the Java program, you need to make a database connection, and then you need to create a statement type object to store SQL queries. And then you submit the query using the connection. So this statement object will be delivered, transmitted to DBMS, and DBMS will process that query statement and access database and fetch results, and then it's going to return the output table to the application. And while DBMS is running the given query, some errors may occur, like maybe the query violated the integrity constraint. Then DBMS will throw an error, and JDBC is responsible for handling those exceptions. So this is an example of JDBC program. I wonder how many of you are familiar with the Java programming language? Just one? Really? Okay. Yeah. Let me think. Okay. No. All right. So then I don't know how to explain this code. Let me just briefly go over it. So this is data type that is used by JDBC. It is used to store database connection metadata. And this is a class name. So to make a connection to DBMS, we need a driver code, DBMS driver code, and this driver manager is managing that database connection and driver. Anyway, this is class name, and this get connection is a method defined inside this driver manager class. And what you do is you specify the protocol type. JDBC is the protocol name, so it looks very similar to HTTP URL, right? HTTP is the protocol, JDBC is the protocol here. And you need to specify what DBMS you are using. If you are using Oracle, this string should be replaced with Oracle. If it's MySQL, you should put MySQL. And JDBC, this protocol and DBMS name should be separated by, colon. Is it colon? Colon. And then when your DBMS is running in a remote host, that IP address or URL should be specified, just like HTTP protocol. And every application requires a specific database, so the database name should be specified here. And then the user ID and the user's password should be passed as the second and third arguments to this get connection method. Then you will get this connection type object. And this connection type object should be used for the following following functions. Initially, we create an empty statement, And this create a statement type, create a statement method returns an object of a statement type, and using this statement variable, you write some SQL queries and then pass it to the DBMS, and then DBMS will return results. And at the end, you need to close that object and also connection. And while this DBMS interaction is occurring, some exceptions may occur, and those, the time level exception of those objects is called the SQL exception. So if anything bad happens, the program will jump to this catch block, and you need to catch that exception using this variable and process that exception in a nice way. Okay, that's the outline, and let's look at the details. Even in Python, the whole structure of this JDBC code will be similar. You need to make a connection and create a variable where you can store SQL query statements. So it shouldn't be very different from what we have in this lecture. Anyway, so statement is the variable that you created in the previous slide. You create a connection and then create a statement and then call this execute update or execute query method with SQL statement. And the SQL statement should be C string. It should be just a string enclosed by double quotes. And then when Java program runs, this method is going to transmit this string into DBMS, and DBMS will parse. It's going to parse this statement and then run the query, and it will return the result. Oh, this is insert statement. So it's not going to return, just it's going to insert this new record into the table, and if no error occurs, we will get out of this try catch block. Okay, that was write query, and for select query, the output will be returned, and the output will be stored in result set type object. And once we get this result set type object, this is basically a table that contains department name and average salary. Oh, there should be only two columns. Anyway, once you get the output table, you should iterate each record and process those records. So here, once you get output table, you enter while loop and call next method. If the table has a single record, then this while loop will be iterated only once. If the output table has two records, it will be iterated twice, and so on. So I'll set the next method is going to move the cursor to the next available record in the output table. And when you call getString or getFloat, these getter methods, the corresponding attribute values will be returned. So the first attribute name is a department name, and second attribute name is what? Average salary. And this getString method got the attribute name here, column name here. So DBMS will return the first column. This rset getString method is going to return the first column's value, and rset.getFloat number 2 will return the value of the second attribute. So it seems we can pass attribute name and a number as an argument to these getter methods. If you are aware of the column name, then you can use the attribute name. But if you do not know, well, if you prefer to use a number, then you can do that. This makes you, this should make you wonder, why is it 1 instead of 0? You know, in DBMS, every number starts from 1. You know, in high-level programming language, as a programmer, we are used to use 0 as the first number, right? In integer, the first element of the array has an index 0. That's what we are used to. But in DBMS, every number starts from 1. Why? Because database programming language, SQL, was developed for non-experts. This DBMS should be used by data scientists. They are not computer scientists, so they are more familiar with. They are more used to using number system that begins with the number 1. That is one reason. So when you pass number 1, it means the first attribute. When you pass number 2, it means the second attribute, and so on. And you should also know the type or domain of each attribute. Here, you must know that department name is string type, varchar type, or char type. Varchar type or char type can be obtained, can be extracted by calling getString method. And if this is an integer type, then you can call getInteger. If it is float type, double type, float type, that doesn't matter. You can call getFloat method to read it. And sometimes an attribute may have a null value inside. How can you check if the value is null or not? You cannot compare it with 0 because null is not 0 in DBMS. So DBMS, this JDBC implemented a special function called wasNull. This wasNull function checks whether the last attribute that we read contains null value or not. Do I have an example? No? Okay. Let's suppose we have right here. Let me stop after this example. So if R set that was system that print out star star star. Okay, let's suppose we have this line right before the system that out the print line here, and let's suppose this select query returned 3 records: computer science, electrical engineering, and biology. And let's say, if we have salary, I don't know. If all salaries are null, then it's going to return null value. Let's just assume that this electrical engineering has null value in the second column. Let's just assume that. And this is 1,000, and this is 2,000. Okay. Oh no, let's say we have another record here, and the first column is null. So when you called this execute query, this rset is referencing this output table, and then we call rset.next. Now we are referencing the first record, and it checks if the last attribute that we accessed has null value inside. No, we don't. We haven't checked anything, so this is going to return false. So we move on to the next line and print out computer science and 1,000. And then we call rset.next again. So we move to the second record, and then what was the last value that we checked? it was 1000. So it's not on. It doesn't have null value. So we move on to the next record and print out electrical engineering and null value. Okay, and then we move to the next record and check whether the last value that we accessed has null value. Yes, right? We accessed this second column. It was null value. Then it will print out this triple star symbols. Okay, that is how. How we check whether a particular attribute contains null or not. Oh, I have a better example in the next slide. Anyway, we are running out of time, so I guess I need to stop and let's talk a little more about JDBC next time.